Hi, welcome back to Speed Math and CS. Today we're going to be continuing our study of AP Microeconomics, and today we are going to be doing Unit 3, which is going to be regarding things such as perfect competition. But let's start off with first, this first part of the lesson is going to be extremely, it's going to have a lot of, it's going to have a lot of impact on how we think of the world, because a lot of what we're going to go over in this first topic is going to be very relevant to what's going on today. Trump putting tariffs and everything. So it's going to be important that we understand this first topic. So essentially, this first topic is going to be about international trade. So essentially, there's three big sort of terms here to understand. So the first one is going to be about the world price, right? So essentially, this is where the countries can buy products at their own domestic price, or they can buy the products at a cheaper world price. So essentially, basically the country with the biggest comparative advantage who will be selling this good will essentially set that world price. So either you can choose to buy directly from that country, right, with terms of trade, which we've covered last lesson, or you can produce it domestically. You can produce it in your own country, and then that will cost a certain amount. And then the next term is a tariff, right, which is a tax on imports, which will increase this world price. So essentially, this will help. It'll essentially take away from we looked at the consumer surplus and producer surplus areas last time. This will essentially take away from the consumer surplus and replace some producer surplus, so that domestic producers are more benefited by this, and also the government can get some revenue. And a quota is a limit on the number of imports, right? So for example, tariffs are essentially going to raise the price, while quota simply it's sort of like a tariff, except it is on the quantity axis. So on the actual AP test, you're mostly just going to see tariffs. I don't think there's been a single test where quota has come up, so we're not going to go over it too much, but it's just in the context of what's going on in the world right now, I guess it's sort of important to understand. So essentially, the purpose of tariffs and quotas is to protect the jobs of domestic producers from a cheaper world price. For example, if producing clothes in China is so much cheaper, so of course consumers are going to buy from there because they have things like child labor and stuff like that, right? While here we don't have that. But let's say there were a lot of jobs. So obviously we would want to put tariffs on China, so our domestic producing of clothes, we have more jobs to satisfy, right? So yeah, and to prevent domestic unemployment, like I said. So going on, right? So purchasing goods at a lower world price looks something like this, exactly how we've been graphing it from before, right? Where we have our supply curve and our demand curve. We label these as S domestic and D domestic, right? So let's look at what happens to the CS and the PS after a trade with a $2 world price. So this is just a domestic price. So this is if they produce domestically. Now with the world price set at $2, this is the producer surplus. As you can see, it's super low. And then this consumer surplus, so the reason it can be this high, right, is that essentially right here, remember last time, if they were producing domestically and they just reduced this price down to $2, right? Normally they would only have this trapezoidal area between the 7 and the 2 and the 10, right? But the reason it can extend beyond the supply is because all of the remaining goods, they get that through imports. So now let's look at what happens to CS and PS after we apply this $2 tariff. So tariffs will raise the price, right? So we'll go from 2 to 4. So all of this, eats out of the consumer's, all of this, if you look before, what was previously consumer surplus, all of this eats out of the consumer surplus, and essentially there's more producer surplus, like more domestic producer surplus, which is what we were trying to achieve. More producer surplus means more jobs and more production domestically and greater like GDP. And then, of course, the tariff is essentially the quantity that consumers will still import, but then so that they're still importing like two like quantity units for an extra price of $2. So that's going to be the tariff that the government is making. But on top of this, there's also some deadweight loss, as you can see represented by these triangles, which will be equal to the tariff. So oftentimes, this is why we look at tariffs. Like most economists absolutely hate tariffs. Like they're so inefficient, and there's so many better ways of increasing the producer surplus. And these two deadweight loss triangles makes it very clear why that is. So now just imagine a Trump doing a 104% China tariff. Imagine how much deadweight loss that's going to cost. So if we look at international trade and quotas, right? These graphs show the domestic supply and demand for grain, right? Where those letters represent area. Let's try to identify the following. The CS if there wouldn't be any trade. So if there wasn't any trade, right? We would just produce normally, right? The CS would just be this H area, right? The producer surplus would just be ILT. So this area, like normal, right? And the amount that we import at the world price, importing will be everything we can't produce. So all of this right here, JKMNRS, all of that will be the amount we import. And the producer surplus, if we trade at the world price, is just going to be this tiny t down here. And then the consumer surplus is going to be all of this. It's going to be HIJKLMNRS. If the government tariff leads to a world price of PT, what is the CS and PS, right? So now on top of T, PS is now LT, right? And the M and S become the deadweight loss triangles. N and R become the revenue that the government gets through tariffs, and now the consumer surplus is HIJK. So we took out LM and RS. So yeah. Let's move on to topic 3.1, which will be the production function. So our first thing will be essentially production means converting inputs into output, right? So let's try to define inputs and outputs. So to earn profit, firms must make products or output, right? Otherwise, how are they going to sell it? How are they going to make money? So inputs are defined as the resources that we use to make outputs. And input resources are also called factors. So you may see this word on the AP test, but to be honest, it's just extra voodoo that economics thought of for many different words to define one thing. But the total physical product, or TP, is basically the total output or quantity produced. This will be like your supply curve. Marginal product is the additional output generated by each additional worker. So this is like your slope, right? And yeah, marginal product equals the change in total product. So delta TP over delta I. So the average product is the average output. It is like the total output divided by the input. So average product, will equal to total product divided by units of labor. So let's go over fixed versus variable inputs. So fixed resources are resources that don't change with the quantity produced, right? And variable resources are obviously resources that do change with the quantity produced. So if we're thinking about this, for example, 3 fixed resources and 3 variable resources for a pizza restaurant, right? So 3 fixed resources could be like dough, like the ketchup they put, like the veggies, things like that. Things that we consider to be in excess, right? And then sorry. So 3 fixed resources will probably be like the factory itself, the ovens, or like the stoves or whatever they used to like cook it, right? And then 3 variable resources, those would be like the bread, the lettuce, and the ketchup, right? Because that depends on how much of the pizza they're making, right? So now let's move on to production analysis. So what happens to marginal product as you hire more workers? And why would this happen? So in this case, we introduce a new law, which will be called the law of diminishing marginal returns. And in fact, we already had a bit of a teaser of this in our very first unit, right? Where we covered the marginal benefit, how with every like new pizza slice you eat, you'll have even less and less benefit. Same thing goes for hiring workers in perfect competition, where the more workers you hire, the less and less they will be able to bring to the table each time. As variable resources such as workers are added to fixed resources, which are ovens, machinery, tools, such like that, the additional output produced from each additional worker will eventually fall, right? And this is a concept that we call too many cooks in the kitchen. So essentially, if you think about it, right, if we start with 1, then one pizza maker is going to be making pizza. But then if we add all of these, if we add like a bunch of people, right, there's not enough ovens or like stoves and stuff, not even enough like materials for all of them to be working. So at this point, this is just a waste of the variable resources. So now let's try to graph production. So if we think about the 3 stages of returns, right? The first one is going to be just our total product, right? Which will look something like that. Very rarely are we actually considering a graph that looks like this, but yeah, so it'll look something like this, right? So as you get more and more labor, your product will go up, but then like as you get to this point where too many cooks in the kitchen, it starts to go below. And then essentially, so if we think about marginal product is simply the slope of this graph. So if we split these into, so if we think about the first stage, which will be increasing marginal returns, this means that the marginal product is increasing as we add more workers. So adding more workers is exponentially causing our business to grow, right? The second, so as MP rising, TP increases at an increasing rate. So now the second area, this yellow area here, you can see that the marginal product is starting to dip. And this is diminishing marginal returns. So this essentially means that, so the MP will start falling and TP will still be increasing, but at a decreasing rate, meaning that we're starting to run out of materials. And this is because we have a fixed resources, and each worker will only add less and less. And now we have this red section, which will be our too many cooks in the kitchen situation. Negative marginal returns. MP is negative and TP is decreasing. So workers getting in each other's way. So if we we can just take a look at this, right? So if we identify the 3 like regions, right? So the first green region, or like the increasing marginal returns, is from like 0 to 3. So up until 3 workers, we get increasing marginal returns. Starting from 3, starting from 4 and onwards, we see the thing where there are too many like people for the fixed resources, so each worker adds less and less. And then so 7 is where we no longer get any marginal product from a new worker. And then 8 and beyond, we have too many cooks in the kitchen, which will be our red part of the graph. So these are the 3 stages of returns. So more examples of these are like the learning curve when studying for an exam, right? So in this case, our input is the amount of time we put to study. So fixed resources, number of class time, textbook, right? So at the start, as we put more and more time in, we're going to get exponentially better results, right? We're going to exponentially increase our score on that final exam. But then later, each additional hour will start to limit us because we've run out of like textbook space or something like that. And then after a certain point, it'll only start to deplete us because we've run out of the textbook, too many hours have been put in, and things like that. And then let's get to the next topic. So for topic 3.2, we're looking at the short run production cost. We're gonna get into long run later, and we're also gonna take a look at this in macroeconomics, which will happen like next week, right? But this is going to be a different context than that. So the definition of the short run is essentially, so we'll look at both, right? So short run is not a set specific amount of time. Essentially, the short run is a period in which at least one of the resources is fixed, right? So we can't we can't change the factory size, we can't change the number of ovens. So long as one of those resources is fixed, we're in the short run. Because the definition of the long run is that all resources are variable, as we learned in Unit 2. So plant capacity and size, the factory is not changeable. And in the long run, all resources must be variable. If not all resources are variable, then we're in the short run. And you can start to see why in the real world, like the long run is pretty theoretical. Like we won't see many situations where we'll be in the long run. So so no fixed resources, and we can change the size of our factories. And then at least for this topic, we'll be examining short run costs. So these will be the different curves that we will have. Like these are like the different variables. These bottom four will actually go onto our new graph that we're learning for this unit. And these are just there. So like total fixed cost is just FC, and then variable costs, like so on and so forth, right? So just keep these variables in the back of your head. We're gonna be graphing these on a graph later. So fixed costs, like we covered, costs for fixed resources that don't change with the amount of produced. And then variable costs are the cost for variable resources that do change as more or less is produced, right? So the cost for fixed resources that don't change with the amount produced, right? So rent, insurance, the land stuff. But for variable costs will be like raw materials, charging more people because we're producing more, we're using more electricity, stuff like that, right? So total cost will be the sum of the variable and fixed costs. And average total cost will be our total cost over the quantity we produce. So marginal cost, right, or MC, will be the additional cost of an additional output. So if the production of 2 or more units of output increase the total cost from 100 to 120, then the marginal cost will be $20 or $10, right? So, So the marginal cost is essentially we take delta T, right? Delta TC, which is $20, and divide it by the quantity, which is 2. That'll be 10. So if we fill out the graph here, right, with the total cost and marginal costs, in order to calculate the average total costs, average fixed costs, and stuff like that, all we have to do is we just have to take the respective column and we just have to divide it by the quantity. So doing this, right, notice that ABC plus AFC equals to ATC. And so for example, for 5 units, AVC will be 12, right? Because under the variable costs, it's $60, divide that by 5, that's 12. And then for fixed costs, take that $10 divided by 5, and you have $2, right? And then, so add those up, and then we get ATC. And if you check that, right, 14 times 5, which is 70. So this makes sense. So this is what it'll look like for each one of these. So now let's actually get to graphing all of these onto a graph. So if you notice, right, this will basically give us a teaser as to what the shapes of our graphs will look like. So the first thing we should notice, right, marginal cost, right, after it crosses ATC, like so, that's when ATC starts to dip. like ATC starts to increase, and once it crosses ATC, it always stays above ATC, right? The reason AFC looks like this is because AFC is just one constant value, and as our quantity increases, we're just dividing that constant value by more and more each time. And then because the AFC is getting lower, the AVC and ATC get closer together as time goes on, right? So as you can see, they start at 20, 10, 10, but then the AFC drops to like around $2, so then they get super close together, right? So that is how the graphs will look, right? So we'll have an MC, an ATC, right? Where the MC always intersects the ATC at the lowest point, right? So just know that. And then the AVC, right, will start far away from the ATC, but then get closer and closer. And then the AFC will be like far away from all of them. Essentially just look like this. So yeah.
One to the server, one to your laptop, one to the iPad, and all the way up with a hot poker.
Wait, sorry. So essentially the average fixed cost is just the difference between the ATC and the AVC, because we noticed that AVC plus AFC, right? That is ATC.
Oh, Kevin.
20. That's low.
Wait, what? Sorry. All right, do you have a question? Okay. Yeah. So ATC and AVC get closer and closer, but they never actually touch because the AFC is always greater than 0. It essentially just asymptotes close to 0. So yeah. So let's calculate the TC, the VC, and the FC of the 5th unit, right? So the 5th unit, right? If we look at, let's do fixed costs first, because those are always the easiest. So if we look at 1 unit, right? That'll be $10. And then if we look at so at the 5th unit, it's going to be the same, right? FC stays the same the entire time. It's a fixed cost. So it's still going to be $10, right? Total cost, all we have to do is we just take this ATC, right? At 5, it looks like about 14 if we're at 5. So we can, ATC total cost is like 70. And then for variable cost, we simply just take this AVC, right? It looks to be about 12 here. So yeah, it is $60. So yeah, we essentially just draw a line and see where it intersects all of them. So yeah, this is essentially what it'll look like. So the total cost curves, right? The FC will be something like this, right? The VC will look here. It's a little jagged, but essentially think of it as just sloping up. And then the total cost will look the exact same as the VC, just shifted up like a little. And then yeah, as you can notice, the fixed cost is the difference between the two. So yeah, so let's do some practice on calculating costs, right? So let's fill out the chart and then calculate the ATC of 6 units and yeah, so on and so forth, right? So if we, the fixed cost remains the same. So everything stays at $20. And then total cost, we simply add the variable cost and the fixed cost, these two columns together. And then for the marginal cost, right? Remember, we just take what the total cost was here, subtracted by what it was last time. So we'll fill out these values. And then all we have to do to calculate the ATC, AFC, and AVC, all we do is we take the total costs and divide it by the number of units. So at ATC of 6 units, right, we head over to 6, we see total cost is 120, divide that by 6, and we get 20. AFC, we do the same thing. We check 2 units, it's 20, divided by 2, get 10. And then we'll do the same thing for the rest of them. So how much, and this is involving marginal cost, right? How much will the 10th unit cost? So on top of the 9 existing units, how much will the 10th unit cost? So remember that marginal cost is representing the additional cost of each like each additional thing that's added on, right? So if we take a look here, the 10th unit, all we have to do is see where it intersects marginal cost, right? So if we draw a line up like this, the cost will be $25 for the 10th unit. So yeah, TC, VC, and FC, we've already done this a bunch, right? It's just we multiply the quantity by the ATC. So yeah, we would just do something like so, where we draw 3 lines and then we just multiply them by 10. Yeah. I think we're good on this. I think we'll be covering this later. So yeah. So getting into the shapes of the cost curves, right? So the reason the marginal cost always goes down and then up, right? This is representing the 3 areas that we looked at before, right? So the relationship between production and cost. As more workers are hired, their marginal product increases and eventually decreases because of the law of the diminishing marginal returns that we covered in 3.1, right? So marginal cost is just invert NP. So that's why it'll look like this. And then the reason that's U-shaped is because if we take like the marginal of the marginal cost, we'll notice that it is just constant sloping up. So this is like essentially the acceleration of the cost if you think about it that way. So each additional worker it'll start like pointed down, because as you add each additional worker, you'll have lower and lower costs, right? But then law of diminishing marginal returns means that the marginal cost will keep increasing over time, right? So eventually it'll pull it back up. So that's why it looks U-shaped. So we can see with this graph, if we plug in the calculations, we'll notice this U shape, right? So it'll start $2, go down to $1.25, and then it will start curving back up to like higher and higher values. So the additional cost of the first 13 units produced falls because workers have increasing marginal returns. So as production continues, each worker adds less and less to the production. So the marginal cost increases, right? Because marginal product is decreasing and the two are mirror images. So now let's look at the relationship between production and cost. So this is putting the second line onto our graph, the ATC. So you'll notice that the ATC is always like, the MC always intersects the ATC at the lowest point of this sort of parabola looking shape. So why does the ATC go down and then up? So when the marginal cost is below the average, essentially think about this, right? This is the average slope, but then MC is like the instantaneous slope. So each additional slope that's being added on, it's gonna pull that average down. But as it goes above the average, it's gonna pull the average up. So this is for example like a test, like the test scores, right? Think about that, right? So if this was the average test score and then we were noticing scores like this, that would pull the average down as we see here. But then if new test scores are above this average, then it'll start pulling this average up. So yeah, when the marginal cost is above the average, it always pulls it up. So we'll always see it intersect at the lowest point because it'll be decreasing and then it'll just start getting pulled up once the MC goes above. Yeah. So if we think about like school, for example, right? So if the semester GPA you earn this semester is lower than your overall GPA, then it will decrease that overall GPA. And if it's higher, right, it will increase it. And if it's the same, right, it'll just stay the same. So the way this applies to MC and ATC, right, is if we looked back at the last slide, right, we'll notice that at the start, maybe your GPA is doing bad. So you're getting bad GPA. So it'll start decreasing. But then as you start getting good and more good GPA, it'll start pulling up. So that's essentially the relationship. So your semester GPA represents essentially the marginal product, right? Or like the marginal cost in this case, right? Each additional like thing that you're adding to your GPA. And then your overall GPA, I keep saying GDP because we're in micro, but each additional like cost will essentially like your overall GPA is like the average of all the semesters. So it represents average total cost in this case. So the shapes of cost curves, right? So actually, yeah, we can just skip this for now, actually, because let's get to the so shifting the let's shift cost curves now. So the AP exam isn't likely to ask you about drawing shifting cost curves. So don't worry about practicing drawing the shifted curves too much. Typically, you'll just put these on the same graph. Because the thing is, right, there's 4 different things. Like, normally we would be like shifting supply and demand. But here there are 4, and we're actually gonna add in a 5th line soon. But there are 4 lines already on the graph. So it's gonna be difficult to demonstrate shifts. And remember that supply and demand is looking at the overall market from a big standpoint. This, like ATC, MC, all of this is like micro. So this is looking at just a single business, not the market. So if fixed costs increase to $200, right? Let's say we apply that here. So increasing these fixed costs will essentially drive up the total costs because total cost equal to fixed cost plus variable cost, right? So then, which per unit cost curves change? So the ATC will change, it'll shift up. And then same thing with the FC. So only AFC and ATC will be increased. And then MC and AVC don't change because MC is essentially a function of VC, right? Because it's the variable costs are each additional cost you're adding, and since fixed costs don't change, you're not marginally adding anything. So if you think about the fixed cost line, for example, it has a slope of 0. So it's not going to add anything to the MC, which represents slope. So MC doesn't change, and AVC doesn't change for obvious reasons. If we're changing the fixed cost, why would the variable cost change? So that one is more obvious. And then shift from an increase in the fixed cost will essentially shift both graphs like so. What if the cost for variable resources increase? So we would shift variable cost, total cost once again, right? But what per unit cost curves would change? So this time, if each additional variable cost is changing, the MC is going to change because the slope is essentially going to be like increased. And then the AFC doesn't change, but the AVC and ATC all change. So all these 3, except for AFC, which is just dependent on FC, all change. So if you look at the shape, shift from an increase in variable costs, we will essentially just be shifting this top part of the graph up. And you can see why doing a bunch of shifts looks messy. Like, look at this graph. It looks very, very messy. Like, imagine drawing this on an AP test when you don't have, like, PowerPoint to just do a drawing like this. So, yeah. So, now let's look at long-run production costs, right? So, the definition of the long run. Remember, the short run and the long run are not specific amounts of time. The short run is a period in which one resource is fixed, right? So, for example, the size and capacity of your factory. And long run, all resources are variable. So, there's no fixed resources. Size of your capacity of your factory can change. So, the long run is used mostly for planning. It's mostly theoretical. In the real world, we're never in a long run. We can't just say, we can just suddenly, we're running out of coal. Well, in the long run, we can actually, there's no fixed resources. Of coal, we have infinite coal. Like, we can't just say that. We're always in the short run in the real world. Long run is solely used for theoretical planning, which is what economics is used for. So, long run, you won't be able to relate it as easily to your real life as short run can be. So, so long run, actually, let's skip all this. this, right? Yeah. So assume you're running a factory producing TVs. So if you double all your inputs, like workers, tools, and machines, what 3 things could happen to your output, right? So first, if your output more than doubles, then you have increasing returns to scale. And then if your output doubles, then you have constant returns to scale. And if your output less than doubles, then you have decreasing returns to scale. So essentially what this means, right? If you're essentially, let's say you're making like a smoothie out of bananas, right? And your inputs are currently you just chuck 2 bananas into a blender and say, okay, hey, now you have a smoothie, right? So essentially what this is saying is if now you double it, right? You have 2 blenders, 4 bananas, and then you make smoothies, right? If you get more than double the smoothie, that means that adding that extra blender and 2 bananas was increasing your returns of scale. If your output doubles exactly, then you have constant returns of scale, or normal, right? Normally, if you double the blenders, double the bananas, it should be obvious that you get double, right? So that's like constant or normal returns of scale. But if somehow you get less than double the smoothie, right, then essentially you have decreasing returns to scale, meaning that adding that extra blender and 2 bananas didn't give you as much smoothie as the first blender and 2 bananas did. So if we skip past this, right? What happens to the average total cost of a product when the firm increases its plant capacity, right? So example of various plant sizes, right? So the first is you just using your garage to make looms, right, with 1 saw. Second is you rent out a building, right, a new factory, buy 5 saws, hire 3 workers. Then you can rent out a factory, buy 20 saw, hire 40 workers. And then you build your own plant and use robots to build looms, right? This is going back to our capital goods we looked at in the first unit. So, and lastly is the biggest one, where you create plants in every major city in the US. So in this case, this represents economies of scale, right? So you start with just doing like one small thing, and then as you build more and more, you produce more and more, right? So the long run average total cost curve is made up of all the different short run ATC curves of various plant sizes. So all of the ATCs, like each one of these 5 bullet points will have an ATC. And the long run ATC curve is made up of all of these short run ATC curves. So this gets into economies of scale. So why do economies of scale occur? So firms that produce more can better use mass production techniques and specialization. So for example, a car company that makes 50 cars will have a very high average cost per car, right? Because you have to pay for the land, you have to pay for the workers who are making them. So they will have a very high average cost per car. But if we're producing 100,000 cars, we're going to be using like machines and things to do this. Our fixed cost, right? If we look at before, the AFC is going to be decreasing as we produce more. So that sort of plays into the economies of scale. So using mass production techniques like robots, capital goods, which will cause the total cost to be higher, but the average cost for each car would be significantly lower. So the long run average total cost, right? If we're thinking this is our first, like we're making a car in our garage. Second, we hired 3 workers, take 5 machines. So now we have lowered both the costs. So now and for this, we graph all of them on the same graph. And then now we now shift to like a building, and then we have multiple different workers building the cars. And then lastly, we shift to a factory, and then So then constant return to scale, right? The long run average total cost curve is as low as it can get, right? So diseconomies of scale are when the long run average costs increase as the firm gets too big and too difficult to manage. So for example, if I was running, for example, like speed, math, and CS over over like the entire world, right? That would be very difficult for like me to manage, right? Because I would have to manage like in each region, and there's like 200 different regions I would have to manage. So this is what we call diseconomies of scale. And these are all the short run average cost curves. We just stuck them onto the same graph. So the long run average cost curve happens when we merge all of these together. So look at that, right? Looks pretty sweet. So this is our long run average total cost curve. And essentially this graph can be split into 3 sections. First section, economies of scale. As we produce more and more, we will lower our average total costs. And then constant returns to scale. As we produce more and more, we will have similar average total costs, right? And then diseconomies of scale is the last one, where it gets difficult to manage. So as we produce more and more, our average cost will increase, right? But for the most part, businesses will try to stay in this economies of scale section. So on an actual AP test, this is what the long run average total cost curve will look like. If the problem just gives you this long run average total cost curves, and it's just like, in economies of scale, what does the shape of this curve look like? Don't put, it looks like a U, because in economies of scale, we're only considering the part where it goes down, such like this. So be careful to read the questions where they involve long-run average total costs. So the law of diminishing marginal returns doesn't apply in the long run because there are no fixed resources. So imagine that Hyundai is building a new $388 million plant, right? So this is essentially, we'll think of this as a long-run decision, right? Because 388 million, right? It's a very big plant. Is the cost of a new plant a fixed or a variable cost? If we make a new plant, right, we can produce as many cars as we want inside of there, right? We can produce 1 car, we can produce 100 cars, and the cost of that does not change. So it is a fixed cost. The cost of new plants, new machines, things like that are usually always fixed costs. And then why do you think that Hyundai decided to build a new plant rather than use that money to hire more workers? So the reason this happens is because it's going back to the too many cooks in the kitchen example that we looked at earlier, right? If we have too many people, like too many workers working on one thing, then it's going to be hard to manage, right? So we make more factories where we can basically put those other workers, and with the additional space and stuff, they'll be able to produce much more. Let's go on to topic 3.4, which will be our types of profit. So let's start off looking at revenue and profit, right? Total revenue is price times quantity, right? So it's that rectangle that we looked at from earlier, right? We sort of teased this in unit 2, but it's important that we get back to this topic in an official 3.4 topic. So profit, once again, we've already seen this. Total revenue minus total cost is profit. And then now this is actually a bit of like a sort of engagement sort of thing, right? Where we're looking at accountants versus economists. So accountants only look at explicit costs, right? Remember, explicit cost, implicit cost. Explicit cost is like the actual cash, the actual like money that we're spending on things. Implicit costs, right? Out-of-pocket costs are payments paid by firms for using the resources of others, right? For example, rent, wages, materials, electricity, bills, things like that. But accounting profit is equal to total revenue minus accounting costs. But economists, like us, like you and me, examine both the explicit costs and the implicit costs, right? So implicit costs, remember, are like what you could have done instead, right? Like meeting your friend if you have to cut down on that time in order to do works and things like that, right? Is the implicit costs. So implicit costs are the opportunity costs that firms pay for using their resources. So for example, they could have made wage, they could have made rent, and they could have had more time, but instead they decided to spend that into doing a business. So economic profit equals to total revenue minus economic costs, which are explicit plus implicit. So if you think about it, right, accounting profit is always going to be greater than economic profit, right? So actually, So from now on, we're going to assume that all costs we discuss are economic costs, right? So example, if the average cost to produce a pizza is $4, and that $4 will include explicit and implicit costs, right? So ignore the fact that we talked about accounting, things like that. All costs going forward are economic costs. So let's move on to topic 3.5, which will be maximizing this economic profit. So short-run profit maximization. What's the goal of every business? Make profit. To maximize profit, that firms must make the right output. So what this means is that firms should continue to produce until the additional revenue from each new output equals the additional cost. So let's assume the price is $10. What should you produce if the additional costs of another unit is $5, right? So of course you should produce, right? Because you're gonna sell that additional unit for $10 and you only cost $5. The unit only costs $5. So you'll make $5 of profit. So if the additional cost of another unit is $9, you're still making profit, right? You'll still make it. But if it's $11, you'll be like, hey, I'm gonna start losing money. So maybe you won't think about it. So this is where we get into our we'll get into shutdown rules soon, right? So how many units should you produce in order to maximize profit? And this is where we get back to our holy grail of AP microeconomics, marginal cost, MR equals MC. We use this in the first unit, we use this in the second unit. We use this in the first unit for marginal benefit, marginal cost. We use it in the second unit for supply and demand. We're bringing it back for the third unit. Marginal revenue equals marginal cost. This will simplify so many problems on the AP test, I'm telling you right now, and will clear up so many confusions. So all we have to do, it's not so much longer an X marks the spot, but MR equals MC. Look for that point. That point is right here. So to maximize profit, we want to produce an MR equals MC. So 4 should be the quantity. We shouldn't produce 5 because for the fifth unit, we're gonna have more marginal cost, and we shouldn't produce at 3 because we could keep getting more revenue. So this, like I mentioned, holy grail of microeconomics. This is like the one thing that if you don't know this on the AP test, you're done for. MR equals MC. You have to know this going into AP test. So let's take a machine analogy, right? Imagine a machine that gives you $40 whenever you insert cash, right? The only rule is that the value of the money you insert must be higher than the previous amount you inserted. So if you think about it, you're gonna be willing to pay as much as you can until, for example, this is literally a money generator at this point, so long as you don't go above 40, right? So you will want to keep putting in money so long as you don't cross that 40 mark. So you'll want to put in a $1 because then you'll get back a 40 return. Then you'll put in a $2, then you'll get a 38 back in return, right? So although you do get more from the first one, you won't just stop at the first one because you could still get more and more money. You'll only stop once you get to 40. So yeah, let's move on to topic 3.6, right? The firm's short-run decision to produce and long-run decision to enter or exit a market. So this is where we get in. So essentially, this long name here is just think of it as this is the topic where we look at if a business shut down or not. Topic 3.6 is the shutdown topic. So essentially this whole topic is going to be based on, hey, should we still produce or should we shut down? And believe me, businesses take all of this into concern all the time when developing businesses. So to produce or not to produce is the big question. So assume a firm produces 10 units and sells each one of them for $10 each. Their average total cost is $15 and their AVC is $8, right? Let's calculate the following. Their total revenue, right, if they produce 10 units for $10 each, right? That's $100 total revenue. Total cost is average total cost, right? 15 multiplied by 10, which is 150. And the variable cost is 80. Fixed cost is just variable cost, is total cost minus variable cost. So $7 multiplied by 10 is 70. So profit or loss, because we have $150 in cost, $100 in revenue, that's a $50 loss. And in the short run, should this firm continue to produce or shut down? So first, $100, 150, 80, 70, right? The profit or loss will be a $50 loss. But actually, this firm will continue to produce because the thing is, right? What we're going to do is to decide if the business should continue to produce or should shut down is look at this, right? If they shut down, this doesn't mean like they're quitting the business. This means that they're just not going to produce anything. So they're still going to pay the fixed cost, right? So it's still going to be a loss of $70, right? But at least if what they're currently making is higher than the fixed cost, if they're losing $100, then they can just shut down. They're better off just gain a $70 loss. So we're going to look at these questions 4 and 5. Fixed cost versus the loss. The loss right now, we're only losing $50 by producing, right? But we're going to lose $70 if we keep producing. So the firm will continue to produce. So in this case, right, if we calculate these 4, right? Let's look at our profit or loss, right? So in this case, right, the total cost is $300 and the total revenue is $160, right? So if we subtract these two, we will get $140. So we have $140 loss. So now if we're comparing these two, right, profit and fixed costs, right? Currently, by producing, we're losing $140. But if we just stop producing, we only have to pay the $100 fixed cost. So they should just shut down. It's better to shut down and lose that $100 in the fixed cost rather than continue to produce and lose $140. This is a shutdown rule. A firm should continue to produce as long as the price is above the AVC. When the price falls below the AVC, then the firm should minimize its losses by shutting down. Why? If the price is below the AVC, the firm has a loss that is bigger than their fixed cost, so they should shut down. Shutting down and producing nothing would be better than producing and having a larger loss. So now, let's look at the graph, right? So, in this case, if we think about it, right? Yeah, so shut down and produce 0, right? Minimum AVC right here is the shutdown, essentially. So we could just, So now we introduce the 5th curve into our graph. Well, in this case, we don't have the AFC, but the 5th curve into our graph. We will have a price curve, which will represent the price that we're selling goods at. If we choose to produce at 5 units, right, the price is below the AVC, which means we automatically shut down. If the price is touching the AVC, it it doesn't really matter. But because like it depends. We can choose either shut down or produce. And if the price is above the AVC, we continue to produce. If the price is touching the ATC, that means we're making $0 profit, $0 loss, right? And if the price is above the ATC, we're making a good profit. So our business is working. So notice what I just did there. We just deleted this entire bottom part of the MC, right? Because if the MC goes below the AVC, we don't care about it anymore. We're just gonna shut down. So this looks a lot like a supply curve. And in fact, in unit 3, this exact function will be a supply curve. When price increases, quantity increases. When price decreases, quantity decreases. So the MC above AVC is a short run supply curve. So if we look at it like this, right? If variable costs increase, right? We will shift it like so. And then when MC increases, the supply essentially decreases. And same thing vice versa, right? So what if variable costs decrease, right? So for example, if the government gave a subsidy to this business. So in this case, we will be shifted in the reverse direction, right? We'll do something like so. It functions essentially just like supply. So entering and exiting in the long run, right? So businesses have to decide if they want to enter or leave a market. So assume that a firm is producing 10 units and sells each one of them for $200 each. Their average total cost is $120 and their AVC is $100. Let's calculate the following. Total revenue, total cost, profit or loss, in the long run, would other firms want to enter the market or leave the market? So start off with total revenue. Essentially, all we have to do is multiply 200 by 10, so 2,000. And then for total cost, take the average total cost of 120, multiply it by units. There we go. Profit or loss. So in this case, we're gonna have an $800 profit because the total revenue is bigger than the total cost. So we just subtract the two, we get 800. Let's think about this fourth question. In the long run, would other firms want to enter the market or leave the market? So in fact, other firms would want to enter the market, right? Because if you think about it, right? They see that, oh, this business is making $800 profit. Look at how much profit they're making. Why don't we join in on this business? Clearly it's working for them and we can get a share of that sweet, sweet profit. Because, well, remember, what is the goal of businesses? To get profit. So if this firm is making profit, other firms would have the incentive to enter the market so they can make profit. So the barriers to entry and profit, right? Barriers to entry are essentially the factors that prevent new firms from entering a given market. So our market with low barriers has more competition and individual firms make less profit. A market with high barriers has less competition and individual firms make more profit. So let's think of a market that has low barriers. Restaurants, right? Starting a restaurant, at least compared to other businesses, is not too hard. A business with high barriers, let's think of electricity companies. In order to supply electricity, you have to set up all the electric lines that'll go to all the houses. You have to set up the ways you're gonna get electricity. You're gonna set up like the coal mines. You're gonna set up the hydropower. You set up the wind power. Like, there's so much stuff you have to do to set up electricity. Electricity is such a high barrier. So essentially, this is actually teasing into Unit 4, but this is where we'll take a look at things like monopolies, where there's only going to be one electricity company because they own all the wires, they own all the coal mines, they own all the hydropower plants, things like that. Normal profit, right? In an efficient competitive market, firms that have identical product will make normal profit. They will break even, make no economic profit, right? Let's think of a traffic analogy. When there's heavy traffic, why do all the lanes go at the same slow speed, right? Because if you think about it, you as a car, you'll look into the other lane, right? The other lane is going so much faster, right? So you'll want to go into that lane. Because let's think of speed as profit for a second, right? So the other lane is going faster. They're going to make more profit because they're going to save more time, right? But so other cars will have an incentive to go into that lane, right? Now, what always happens as soon as you leave that lane and go to the fast lane? That lane will slow down, right? So this, and then the lane you were just in will start going faster. And then at the end, everyone just reaches the plates at the same time, and it was just a useless effort to try and move lanes. So that is like, in traffic, cars are in perfect competition. Like, I know that's an interesting example, but like that's, I'd say, like a very good example of how essentially like perfect competition businesses work, right? Now let's get into the juiciest topic of this unit, which will make up pretty much this entire unit we've been leading up to perfect competition. So this will be the biggest topic by far of this unit. So first, let's go over the 4 market structures. So the 4 market structures, right? We have perfect competition, monopolistic competition, oligopoly, and monopoly, right? Every product is sold in a market that can be considered in one of the following above market structures. Today, we are going to be looking at the first one. So for example, a fast food market, car manufacturers, market for operating systems such as Microsoft, strawberry market, cereal market, right? For cereal market, right, you'll notice all the cereal companies are made by similar brands. So cereal is like an oligopoly. Strawberry market, right? You can't make strawberries different, right? The only way to make strawberries is just stick them up and like produce them. So, and also it's very low barriers to entry to make strawberries. So it's going to be perfect competition. A market for operating systems such as Microsoft, that's a monopoly. You can't just suddenly start making computers, things like that. You can't just suddenly start making operating systems. It's a high barrier to entry, so businesses find it difficult to compete with things like Microsoft. So that'll be a monopoly. Car manufacturers are more into the monopolistic competition. You can make a car better or worse. There's so many different types of cars. So that will be monopolistic competition. And like a fast food market, that's also monopolistic competition. All the fast food restaurants sell some good or another. Like, there's multiple different fast foods you can make. Essentially, perfect competition is when there's only one way to make that one good. So things like strawberry markets, bottled water markets, all fit under perfect competition. So we're going to be starting with perfect competition, and unit 4 is going to be, we're going to look at all of these other 3. So characteristics of perfect competition: corn, strawberries, milk, things like that. You can't, like, milk is a bit of an iffy one because you can make milk differ from each other. Like, you can add omega-3, things like that. Like, businesses have found a way to make it monopolistic competition, right? But like strawberries, you can't make strawberries differ from each other. You just grow them and sell them. Similarly with corn, you can't make corn different, right? Corn will always be the same. So that's typically what we will see with perfect competition. Things that will always be the same. So ultimately, like, all the businesses are equally competing with each other. So yeah. Many small firms, identical products. Identical products, e.g. perfect substitutes, is the biggest sign of perfect competition. Low barriers to entry. It's super easy. You just stick corn seeds in your backyard. Bam, you have a corn business. Stick strawberry seeds in your backyard. Bam, you have a strawberry business. Once again, I said milk is a bit iffy because, like, getting cows in your backyard may be a little harder than these. So milk is still a little iffy. But seller has no need to advertise. All the strawberries are your same. How are you going to differ your strawberry from another? And firms are price takers. If you think about it, if everyone else is selling a strawberry for $2 and you make the strawberry $3, right? No one's going to buy it. you have to take that price everyone else is taking, produce it at $2, right? So you can get a share of that. So that's essentially what perfect competition is. And each firm has no control over the price. So if we look at a monopoly, right? Some characteristics of a monopoly, for example, the electric company, Electrics, De Beers is like a diamond company, right? They own all the diamond mines. So there's a super high barrier of entry, right? You literally have to go create your own diamond mine to compete with De Beers. Because they own all the diamond mines. So they're the only ones producing it, right? One large firm where the firm is the market and they have a unique product, right? No close substitutes, right? So De Beers is making a diamond and let's say someone else is making a different type of jewelry, like a gold, right? So there's not going to be any close substitutes to a diamond that isn't a diamond itself that De Beers is selling because De Beers owns all the diamonds. High barriers, right? If we go back to De Beers, right? You have to literally make your own diamond mine. You have to on your own find diamonds somewhere, right? And yeah. And then same with the electric company. You have to set up all the wires, set up all the coal mines, set up all the hydropower plants. So firms, it's very hard to enter the industry. And monopolies get to set their own prices. Barriers to entry. A monopoly wouldn't last long if there were not high barriers to keep other firms from entering, right? So if you think about it, right? If corn making was a monopoly, right? But making corn is super easy. You just stick corns in your backyard. Why wouldn't other businesses want to join in on the profit and then look for that? So monopolies will always have high barriers to entry and to keep other firms from entering. So some types of barriers to entry, right? Economies of scale. If there's only one electric company, they're the only ones that can make electricity at the lowest cost. This is what we consider a natural monopoly. If others start making electricity, they have to build more wires, things like that. If an electric company is already established, they can produce it at the lowest cost. They're the most allocatively efficient, so we want them to be the only ones producing. They could have better technology because they've been doing it for a while. Geography, ownership of raw materials. If you're like De Beers, they own all the diamond mines, so they have all the ownership. Government created barriers. For example, if the government says, okay, we can only have one electric company, right? So the government could create barriers. So if the government issues patents to protect inventors, right? So for example, let's say you were making diamonds, right? And then you made a patent. Hey, this is what a diamond looks like. This is mine, right? That's could be a government created barrier. You just made a monopoly for yourself. So if we're looking at oligopoly, right? Characteristics of oligopolies, right? Cell phones, service providers, cars, there will only be a couple, right? So for service, right, there's T-Mobile, AT&T, right? Maybe Verizon, maybe there's some new ones, I'm pretty sure, but AT&T, T-Mobile, they're an oligopoly. They're gonna, there's essentially oligopolies, once again, a few large producers. This less than 10 is just a general estimate, right? Identical or different or somewhat differentiated products. They can, for example, for cell phones, right? If you think of Android and iPhone, right? They're selling two completely different products, right? And they're the ones who probably patented it and invented it on their own. High barriers to entry. You can't just at home make yourself a cell phone. It's not how that works. You can't just set up all the wires to become a new service company. And then you can't just make a car at home. So these are some high barriers to entry. And then they control their price. They're also price makers. Firms must worry about the decisions of their competitors and use strategy. This is mutual interdependence. Lastly, if we take a look at monopolistic competition, the characteristics of monopolistic competition. For example, fast food, furniture, shoe stores, relatively large number of sellers, right? The products are all different. So if you think about fast food, right, there's Taco Bell, Subway, McDonald's, all these different things. They're selling different things, right? They're not gonna each be selling just one burger. Like, products are differentiated. They have some control over their own price, right? Because they're gonna be somewhat the only one producing it, right? Usually low barriers to entry. That's why there are going to be a large number of sellers, because it's super easy to go start a restaurant. You just start making stuff in your kitchen and boom, you can make a restaurant. So this is the type of market structure where we see advertisements, right? So a lot of non-price competition, such as advertising, because they don't have control over their price. So they have to convince people if we think back to revenue, right? Revenue is price times quantity. In a monopolistic competition, if they don't have control over their price, right? How would they increase their revenue? They have to increase their quantity, right? In order to increase their quantity, what is quantity? It's the amount of people buying your product. How do you increase the amount of people buying your product? You advertise. That is what characterizes monopolistic competition. So let's actually skip this, right? Let's get into the actual perfect competition. So first time, many small firms, identical products, low barriers, easy for firms to just start. You can just plant strawberry seeds in your backyard, bam, right? Seller, there's no need to advertise, right? You're not gonna get more people, my strawberry is better than all the other perfectly identical strawberries. You should come buy mine. What's the advantage? There is no advantage. So the seller, they're not going to benefit from advertising. They're just increasing their fixed costs by doing so. Firms have to take the market price. They can't make their own price. We already discussed this. They have zero control over price. Demand for perfectly competitive firms. Why are they price takers? Because if one firm charges above the market price, right? No one is going to buy. They will go to other firms. So there is no reason to price low, because consumers will buy just as much at the market price. Since the price is the same at all quantities demanded, the demand curve for each firm is perfectly elastic, right? Or in essence, a horizontal straight line. So the competitive firm is a price taker. Price is set by the industry, right? So if we're taking a look at an industry like so, right? We're gonna have a demand curve and a supply curve. Supply and demand. This is the industry, all firms. If we take a look at an individual firm, this is everything that we looked at right now. Demand is constant, right? Yeah. So essentially, if we're looking at this, right? We're going to convert this price curve into a thing called Mr. Darb, right? I know, but this is like one of my favorite acronyms, right? And it's very helpful to use this to memorize, right? So So the first unit earns $10, next unit earns $10. Marginal revenue is constant at $10, and notice that the marginal revenue equals the average revenue, which is the price, and this equals the demand. So now this is Mr. Darb, maximizing profit, right? So for short run profit maximization, what is the goal of every business? Maximize profit. To maximize profit, firms must make the right output. So firms should continue to produce until the additional revenue from each new output equals the additional cost. So for example, assume the price is $10. Should you produce if the additional cost from another good is $5? Yes. If it's $9, yes. If it's $11, maybe not, right? So once again, we're getting back to our profit maximizing rule. MR equals MC, the holy grail of microeconomics. Let's put cost and revenue together to calculate profit. So if we do something like this, right? And we have cost and revenue. Revenue or marginal revenue essentially is, so this is our marginal revenue, right? How much output should be produced? MR equals MC, right? We just go look down at this, right? That's 9. 9, and then price is 7. So we should produce 9, right? How much is total revenue? And how much is total cost, right? Is there profit or loss, and how much? So total revenue, 9 times 7, right? That's going to be 56, or 63, sorry. 63, and total cost is we just take this ATC down here, 9, put it up here, and then draw it across, 5. So 5 times 9, 45. So if we subtract it, right, there will be a profit of $18. So if the Mr. Darp is, so suppose that the market demand falls. What would happen if the price is lowered from $7 to $5? The MR equals MC rule still applies, but now the firm will make an economic loss. The profit maximizing rule is also the loss minimizing rule. So if we look at something like this, right, where the cost is more, right, we will use the same thing, where we will produce at 7, right? MR equals MC, holy grail, remember that, right? We have minimized the loss to $7. Assume the market demand falls even more. If the price is lower from $5 to $4, the firm should stop producing. Shutdown rule. A firm should continue to produce as long as the price is above the ABC. When the price falls below the ABC, then the firm should minimize its losses by shutting down instead of continuing to produce. So why do we do this? Because if the price is below the ABC, the firm is losing more money than their fixed costs. They should produce nothing in order to minimize their loss. So they will just shut down and produce 0. So minimum ABC is the shutdown point. So now let's look at Mr. Darp once again. Total cost $35, right? Mr. Darp, $20. We just take 5 multiplied by 4. And the fixed costs are $10, but the price is below the ABC and they should shut down. Producing nothing and taking their fixed costs as a loss is cheaper than producing 5 units. MR equals MC. 3 characteristics of this rule. First, this rule applies to all market structures. It applies to everything. MR equals, whenever in doubt, MR equals MC. Get this literally drilled inside of your head. MR equals MC. This rule applies to all market structures. This rule applies only if price is above ABC. If the price is below the ABC is below the ABC, we just shut down, right? The rule can be restated as P equals MC for perfectly competitive firms because MR equals P. So, yeah. Let's do some practice, right? First question, should the firm produce? If we look at Mr. Darp, it's well above the ATC. They're making a profit, yes. What output should the firm produce? MR equals MC, 10. What is the total revenue and total cost at that output? 10 times 14 is their total revenue, 140. 10 times 10 is 100, so that is their total cost. How much profit or loss? Total revenue minus total cost, 140 minus 100, $40. There we go. Let's actually move on. I think that this should make sense. Let's get into some chart practice, right? So assume that the firm can sell each unit at a price of $30. How many units should the firm produce in order to maximize their profit? What is the total revenue at that quantity, and how much is the profit? Okay, so assume the firm can sell each unit at a price of $30. Okay, so if they're selling each unit at a price of $30, in order to maximize profit, we are going to look at MR equals MC. So remember, price equals to marginal revenue. So MR is 30. So essentially, because these are discrete values, we just keep going until we exceed, right? So 30 is about here, so we'll produce 5. what is the total revenue at that quantity? We multiply the price is $30 and we're producing 5. So we're gonna get $150 in revenue. Now if we're looking at costs, right? Total cost at this point is $80. It's just given to us right there. But another way we could look at that is we could just take the variable cost, the fixed cost, and add them up, right? So 100 minus 80 is 20. Yeah, so notice at 6 units, the firm is still making profit, it's just not maximizing it. So if we do something like so, we'll see that we maximize it at 5 units. Remember, MR equals MC, and then for a discrete table like this, we take each value, each value in the marginal cost table, right? We keep going until it is about to exceed the marginal revenue. Once it exceeds, we go back to the last point where it wasn't exceeding, and we take that as the maximum. Short run supply curve, right? So if it is below this, we shut down. So as price increases, the quantity produced increases. So we have the MC above the ABC is just our short run supply, right? If variable costs increase, right, we shift it like this. We've actually already seen this. So we can just speed through this. But now, what happens to quantity if fixed costs increase, right? So if for fixed costs increasing, right, the ATC will shift up, the AFC will shift up, but the MC doesn't change, which means our rule of MC equals MR still stays the same. So yeah, quantity stays the same because the MC/supply doesn't change. The AC just goes up. Now let's look at per unit versus lump sum. And this will be used in things like taxes. So a per unit tax or subsidy affects the variable costs. So MC, AVC, and ATC will shift. This will affect the quantity produced. A lump sum tax or subsidy only affects fixed costs. So only AFC and ATC will shift. MC stays the same. This will not affect the quantity produced. Let's go on to shifting cost curves, right? So a change in fixed cost changes ATC and AFC, but not MC. A change in variable cost changes ATC, AVC, and MC. So yeah, changes in cost don't change in output. Let's actually. Sorry. So let's draw side-by-side graphs for a perfectly competitive industry and firm. So, and then let's look at if the firm is making a profit or a loss and why. So let's look at this, right? In this case, if we're producing at 8 units, right, we'll notice our Mr. DARP, or in this case Mr. D, is above the ATC. So in this case, right, marginal revenue is above the average total cost, so we're making a profit. So which of the following is a correctly labeled graph for the firm making economic profit? So if we look at what's wrong with the first one, right, we can see that we aren't going fully to the thing. Like you'll see ATC is this section, and we're not taking MR equals MC. So in this case, right, we're not at the output point, so this is wrong, right? For number 3. Yeah. So in the case of number 1, they're making a loss, right? For number 2, right? If we look at it, MR equals to D, right? We're not at MR equals MC. MR equals MC is at this point. So this is also wrong. If we look at number 3, we are at MR equals to MC, but strangely we somehow dip below the ATC. And then in this case, this is all right, but then we labeled the ATC at MC wrong. They're all wrong for different reasons. Yeah, so let's look at a graph like this, right? Where is the profit maximization point? And how do we know? So the profit maximization point is MR equals MC. That rule is so important. We're going to literally be using this all the time. MR equals MC. So the MR equals MC is 10, right? So we should produce 10. Total revenue is, we simply take this marginal revenue, right? That is our total revenue. Total cost is just this average total cost multiplied by the 10 thing, right? And that will be our profit. The shutdown point is at the bottom of the ABC. So right there is the point where we should shut down. Let's look at perfect competition in the long run. Let's say you're a wheat farmer. You learn that there is more profit in making corn. What would you do in the long run? Of course, you would shift to that corn business, right? Because in the wheat farmer, you're making less profit. And there is more profit in making corn, so you'll shift. This should be obvious, right? In the long run, firms will enter this as profit, firms will leave if there is loss. So all firms break even, they make no economic profit. No economic profit equals to normal profit. In perfect competition, if you're a corn farmer, if you're a strawberry farmer, so things like that, normally you are going to be making zero economic profit. But remember, if we're thinking about accounting profit, you're still going to make accounting profit. It's just that there's not going to be benefit from switching to one or another, right? So in long run equilibrium, a perfectly competitive firm is extremely efficient. And remember why a competitive firm is extremely efficient, right? Or what denotes efficiency? Our DWL, right? So remember at the start of the unit, in the unit, right? We were looking at why tariffs are inefficient. So Trump making all these tariffs causes big DWL triangles to form, right? Deadweight loss equals inefficiency. But in a competitive firm, there is zero deadweight loss. So competitive firms, perfectly competitive firms are extremely efficient, right? So if we look at this, right, we'll notice that the marginal revenue, marginal cost, there is zero deadweight loss. So that's why it's efficient. If we look at a firm in a long run equilibrium, it'll look something like this, where the Mr. Darb is at the bottom of the ATC, like so. Price equals MC equals minimum ATC. Firm is making zero economic profit. So like we mentioned earlier, they do make positive accounting profit, right? But when we're including the implicit costs, like the opportunity that they could have shifted to another, they break even. So there's no benefit for producing in this versus another industry. So there's no incentive to enter or leave the industry. Let the corn producers be, let the strawberry producers be, go to some monopolistic competition and maybe start a business there, right? There's no incentive to enter or leave the industry because they're not making any profit. Yeah. So going from the short run to the long run is the next topic, right? So first, is this a short run or the long run? And why? So in this case, right, we'll notice the Mr. Darb is above the ATC. So in fact, it is not in the long run. It's in the short run. In the long run, firms will enter the industry, which in price and quantity, this will drive the price down, and this will essentially increase the supply, right? Shifting the supply curve to the right. Shifting the supply curve to the right will cause the price to go down and the quantity to increase. So they'll produce more the quantity in the industry and more, but the price will go lower. But in this case, when the price goes down, right, the quantity will also go down for the firm because there are more firms splitting that quantity. So it'll look something like this. So we're going to shift down, but we increase here. Price falls for the firm because they're price takers. Price decreases and quantity decreases. And the new long run equilibrium at a $10 price, zero economic profit. So if we look at this, right? This is still the short run because we're making a loss. In the long run, firms would want to leave the market, right? So firms leave to avoid losses, so supply decreases in the industry. This supply curve shifts to the left, which will cause the price to go up and quantity to shift to the left. But in the business itself, you'll see this MC is always positive sloping. So whenever the price increases, they will always want to produce more. Yeah, so something like so. Where price increases, quantity increases. Price increase for the firm because they're price takers, and now they're at long run equilibrium. Yeah. So I know that this name sounds very counterintuitive, but we're going to be going from the long run to the long run in this next sort of section. So yeah. So we're going to get into the constant cost industry, right? Where new firms entering the market do not increase the cost for the firms already in the market. So if we look at something like this, right? We're currently in long run equilibrium. So if demand increases, what would happen in the short run, and how does it relate to the long run? So in the short run, if demand increases, we would increase the price and produce more, right? All right, firms will enter to earn profit, so supply increases in the industry. So the price will return back to $15. So right now we have essentially shifted into a place where now we're just producing extra. There's just more firms in the thing. So how do we get from this long run back to the old long run? So the only thing that changed from the long run to the long run is the quantity in the industry. So like so. In a constant cost industry, the long run supply is horizontal. What if demand falls? If demand decreases, what would happen in the short run, and how does it return to the long run? So in this case, demand will decrease, right? So price and quantity decreases, loss is made in the short run, right? So, but then firms will leave the market, so supply also decreases. So this would shift it up, and they're in a new long run. So yeah. Yeah. So this is going from the long run to the long run. I know. Pretty counterintuitive. But yeah, I think that's where we're going to end off today. We will finish up like the short part about perfect competition. Next lesson, we will be getting into the other firms. Monopolies, oligopolies, monopolistic competitions, things like that. But we are going to be discovering the other three imperfect competitions, and we are going to see how all four of these relate together. The next unit will be market structures. So I hope you enjoyed. Drop a like, drop a subscribe, and if you haven't already, check out the practice on Homework Speed Math, cs.glitch.me. Very helpful for practice, and we recommend this to we recommend that all our students use this incredibly helpful resource to practice. But anyways, that's it for today. So I guess we will see you in the next one.